Hello. We're almost at that time of the year. Here we are at week number 13. Let's see. Week 13. Um, Damn, that was fast. Yeah, we only got a couple more weeks left. So let's see. Today we're going to talk about data science. In particular, we're just going to introduce a library, a Python library called Pandas. Hold up. Let me look at the future real quick. Let's see. So we got data structures. I might have to shift some of these things around. I'm thinking about putting data structures to next week. But anyways, we're gonna cover data science today. I think we're gonna take 2 days to cover this. We're probably gonna do the lesson number 18 today, and then you'll actually have enough to do this next programming project. It's pretty much the same exact project as before, the Major League Baseball players, but this time is going to involve using this library called Pandas. We'll talk about this in a bit. But yeah, it's literally the same exact assignment, but it's arguably going to be easier because we're going to be using a library to do most of the work for us. So yeah, by the end of today, we'll be done with lesson 18, and you should have enough to get this next programming project done. I'm gonna go over the lab probably in a couple days. Excuse me, acid reflux. So yeah, I'm gonna go over the lab in a couple days. It's dealing with a different data set. Okay, so here let me introduce what the Pandas is. So I'm gonna Google this over here. So Pandas Python. Pandas is short for panel data. You can think of panel data like, Google Sheets or maybe Microsoft Excel. Basically, when you download a sheet, it can possibly be in like a format that Python can take, as long as the format is in like a comma separated values, like a CSV file or something. Here's what I mean. Let me pull up a Google Sheets real quick. Okay, hold on. Let me do this on my other screen so I don't leak any information. Okay, I'm just gonna pull up some Google Sheets so you kind of get a sense on what it is. Google Sheets. Give me 1 second, folks. All right. If you've ever worked with Microsoft Excel or Google Sheets, you might be familiar with something called tabular data or panel data. Basically, these are organized by rows and columns. Here I have a sample gradebook. Sometimes it's necessary to export this file, meaning to download it to your local computer or put it somewhere else. So you might find yourself going on File and then downloading. And then when you download it, there's some formats here. In particular, we're going to be focused on right here, the CSV. Basically, this CSV file stands for comma separated values. And if I were to download this CSV file, here's what it looks like. So I'm just going to open it up over here. Let me open it on my notepad so it looks easier to read. Let me open it up. Okay, let me open up in my notepad. Okay, so I just downloaded it. Here's what the file looks like. So this file is named sample gradebook sheet1.csv, and it's pretty much comma separated. The the headers are over here, and then all of the actual data are down here. So this is what the data looks like, and it's possible to import this into a Python library and kind of just do a lot of automatic data analysis on it. Okay, so that's what we're going to be doing today. This is going to be some really useful stuff. There's whole courses dedicated to this. We're only going to be able to spend like 2 hours on Pandas, 1 hour today, and then 1 hour in a couple more days. So Uh, just a quick intro. First of all, there's an install button here, but you don't have to install it because we're working remotely on the Jupyter server. The Jupyter server is already set up with Pandas, so there's no need to install this unless you're working locally. If you have like a Python on your own local computer, then you might find yourself installing libraries. So yeah, you don't have to install this. But if anything, I want to talk about how much this library can do. So I'm going to look at the documentation here, this API reference. It's basically going to have a bunch of things that we're going to be using. This is a pretty big documentation, by the way. It's super big. There's like 1,000 pages probably. But in particular, we're going to see over here on the left, the series and the data frames. Basically, these are like, they're like data structures. And in particular, we'll be focusing on this data frame. So let me just click here. Okay, data frame. Notice how many things there are that we can do with data frames. So I'm just gonna scroll down to the left over here. You see all these things? These are all like functions and attributes that we can do on data frames. It's really deep. There's a lot of things we can do in Pandas. And once again, there are whole courses dedicated to this. If you transfer to like a university or something and maybe take like a machine learning class or an intro to data science, you know, they're going to spend 10 weeks going over pretty much how to use Pandas. So here, let's jump straight into it. So here I'm going to open up the lesson on number 18. Lesson number 18. Okay. Let's see. So yeah, we're going to introduce a library and just kind of the surface level of how this library works. We're not going to jump in. We're not going to dive in too deep. There's way too many things to talk about. So it's just going to be surface level things today. And it's going to be pretty cool. But basically, by the end of the day, you might be able to do the programming project in like 5 lines. There's this Major League Baseball players. If you did this programming project last week, the previous one, you might have seen yourself writing a for loop that goes through a bunch of data and writing a bunch of if statements that does something. You know, you can actually do the previous assignment in like 5 lines, assuming that the Pandas library is doing everything for us. So it's going to be pretty cool stuff. Okay, here, back to the lesson. Okay, data science, here we go. So yeah, we're just going to be loading in data, tabular data, and kind of playing around with it. We're just going to learn how to navigate things. That's really it. Okay. Let's see. First things first, this first cell is importing the Pandas library. We already have this installed on our server, so there's no need to install it. And then this second line right here is calling a Pandas function, which is going to read in a file, the comma separated values file, Major League Baseball players, and then it's going to store it into a variable called df. So real quick, I'd like folks to maybe modify this cell a bit. I kind of want to simplify this scenario a bit. Basically, I'm saying if you could remove this second argument, that would be great. It's pretty much going to change the shape of the data and make it arguably easier to understand. So let me change this cell over here. It is read only, so I have to go on the top right and then make it editable. Okay, so I made it editable, and I go ahead and remove this second argument. Once again, the reason why I'm removing it is to simplify the shape of the data, and it's going to be arguably easier to understand what's going on. Okay, so I just removed the second argument. Let me run it. Since the df is the last statement in the program, in the cell, I mean, a Jupyter Notebook will show us the result of what this is, and the result of it is kind of like a data structure. It's a tabular data or panel data, where each row contains a person's profile. And yeah, you've seen these people before. This is stuff from the previous programming project. So yeah, this is a data frame. It's kind of like a fancy data structure. You can think of it almost of like a list of dictionaries, kind of like the previous assignment. Okay, so let's kind of navigate this data structure. Once again, we're only going to do some surface level stuff. There's so many things we can do, but first we'll start off by accessing certain columns, the vertical things. So the columns, we can probably look at the columns here. So first of all, I'll type in df, and this is going to show us everything. I'll press play. I gotta scroll up. So I typed in df, and once again, Jupyter Notebooks is showing us the result. If anything, you can also look at the columns. The columns here are, you know, name, team, position. The cool thing about this is we can index the data frame with the column names. So if I said df and then index the name, this is going to give us the whole column associated with this. So let me press play here. Control enter, and there we go. It doesn't really print everything because it's too long, but it's pretty much showing us the head of the data and then the tail of the data, the first 5 and the last 5. So this is for the names. And I want to point out that this is it's kind of like a list, but not really. This is actually a series. If you look at the type of this over here, it says it's a series. You don't really have to worry about this too much. It's really just a fancy word of saying like a list/dictionary thing. So yeah, here this is a series. Okay, and we can look at more stuff too. Like here, let me make another cell. Actually, I'm just gonna use the same cell. So let's look at another one, team. So I'll look at the team column over here. So team, and then press enter here. Control enter, I mean. And here it is. Here's like a kind of like a list of 1,000 elements. What else? What else is there? There's position, there's height. Let me look at the height. Okay, there we go. So we got the height here. Yeah, it's just a list of numbers, and the right side is showing all the heights. So yeah, we're just kind of navigating some things. If for some reason you wanted to access individual things, you could use this operator called the I think iloc. I think it's called iloc, which stands for index location. And basically how this works is it's kind of like a fancy index thing where you can put a number inside of these square braces. If I were to put like a 2 here, that this is saying grab this one over here, the element at index 2. So this is going to print out 72. Well, it doesn't really print it. It's saying the value of this is np.int64. This is just a fancy integer. It stands for numpy integer. You don't have to know too much about this, but numpy is another library that Pandas relies on. So yeah, Pandas is a library that relies on another one, and it uses numpy. Okay, so yeah, if you were to print this right here, instead of showing the value, it's going to print 72 here. Okay, so yeah, just kind of navigating some things over here. All right, any questions so far? All right. Yeah, lots of cool stuff. So, okay, let's navigate the data structure a bit more, just to make sure people are cool with this. So once again, the data frame df is this whole comma separated values file. If you were to index by the row, currently the row can be only indexed by these numbers. these bold numbers. So if you wanted to access individual ones, you could do the same thing. You could go like .iloc, which stands for index location, and then put in like 2 here. If I were to put 2 here, this is actually going to give me the whole row. So check that out. I'm going to press play here. And it gave me the whole row of that person. This is actually if you look at the type of it, the type of this is a series. It's kind of like a fancy list / dictionary. Basically, you can think of these left side as keys and then the right side as values. So if I wanted to access individual values, I could use a key over here. So I could say this is like I could get their height over here again. So this is gonna give me 72. This integer right here. If you were to print it, it's gonna print 72 instead of showing it. There it is. Yeah. So these two pretty much do the same. If anything, this first one is indexing into the column first, and then grabbing the element at the row. Or you could grab the row first, and then the key associated with it, value I mean. So yeah, just kind of navigating this a bit. Okay, let's do some more powerful stuff. So mapping, we saw this last week. Basically, mapping means to convert a sequence of items into another sequence. Sometimes it's necessary to convert things, like maybe we wanted to convert the height to all kilograms. So we'll see that in a bit. Imagine this yellow column as it's in US metric system, the US imperial system I mean, and maybe we wanted to make a whole new column that has the kilograms, the metric system. So that would be kind of mapping, where we're translating a column and then adding that column to the data frame. So let's go ahead and do that. Excuse me. Sorry, I'm getting some acid reflux. Okay, so let's look at the weight column. Okay, the weight column right here is a series of numbers. The cool thing about the Pandas syntax is we can divide a whole series by, we could perform math on it. In this case, if I were to, divide by 2.205, well, this is, first of all, if you're curious what's happening, like the reason why I'm dividing it is to convert it to kilograms. But basically, if you take the pounds and divide it by 2.205, this gives you kilograms. So if I press play here, you see how all of the numbers got converted? They didn't really get converted yet. Because, if we look at the weight again, so I'm going to remove this division. If I look at the weight again, it's still in pounds. Right, 180 pounds, 215, all of that. So we didn't really modify anything yet. All we're doing is making an expression, and this expression evaluates to another series. There's a lot of magic happening here, by the way. Basically, this division is happening with every single element in that series. So there's a lot of magic. If we wanted to store this back into the data frame, we could do that. We could do that. All you have to do is assign it. So on the bottom right here, let me just copy and paste it. So I'm going to copy this and then paste it right here. So once again, this is an expression that evaluates to a series. If we wanted to add that series back into the data frame, we could assign it. So I could say, I could assign it here with an equal sign. And on the left side, I'm going to say, hey, create a new column named weight in kgs for kilogram. So real quick here, look, let me back up a bit. So this left side doesn't actually exist yet. If I were to run this, it's going to give me a key error. It's saying that this column doesn't exist. This totally makes sense. We don't have a column that says weight in kilograms, but it's going to exist when we assign it. So the right side will be put on the left side, and this will, since it doesn't exist, it's going to create it for us. Okay, so let me press play here, and there's no output because all we did was assign something. But if we were to put df at the bottom of the cell, Jupyter Notebook will show us what it looks like. So I just press play, and check this out. There is a brand new column here. Brand new column. We pretty much mapped the pounds to a kilogram, and now we can access this column. If we index it right over here, Jupyter Notebook will show us that it evaluates to a series. So yeah, people see what's happening now. Our data frame now has an additional column. This is useful when you want to take a feature and maybe calculate another feature from it. Okay, so let's do the same with the height. The reason why we're converting to height is pretty much because we're gonna calculate BMI, and body mass index relies on the metric system. So if you're curious what's happening, this is stuff from last week. Last week we went over this project, Major League Baseball players, and there is a equation here that defines how BMI is calculated. Basically, it's weight divided by the height squared, but that's assuming they are in the metric system. Since our data set is in the US imperial system, we're using this second formula, which pretty much converts things. Like if you wanted to convert pounds to kilograms, you'd have to multiply by 0.454. And multiplying by 0.454 is the same as dividing by some number. So same with inches. If we get the height and multiply by 0.0 something, this is the same as dividing by some number. Just some math stuff. So that's pretty much what we're doing over here. The weight, if we divide by 2.205, this is the same exact thing as multiplying it by 0.454. Same thing. So yeah, just to get a point across. I know that, I don't think algebra is a requirement for this class, but these two are mathematically equivalent. 0.454. Yeah, these two lines are the same. Okay. So let me go ahead and add another column, the height column. So if we wanted to convert the height to the metric system, basically you just want to divide it by this number. So I'm going to make an expression here that represents the new column. So I'll take the height. This is an old column. And then if we were to divide every single element in that series by 39.37, this expression evaluates to a series. And we should store that series back into the data frame. You don't have to, but I'm going to store it in the data frame so we can access things easier later. Okay, so I'm going to set the expression here, put an equal sign on the left, and say create a new column. So this is going to create a series and then insert it to a brand new column. All right, check it out. So I'm going to press play here, Control Enter, And here we go. We see a brand new column. Pretty sick, right? Pretty sick. So any questions so far? Okay. Let's go into some BMI stuff. The BMI is calculated by division, but basically you're doing the weight divided by the height squared. And if you're in the metric system, then this should work fine. So we could map again. Maybe we wanted to add a BMI column. Currently, our data structure doesn't have a BMI column, but maybe you wanted to. So in that case, we need to create a series that represents the BMI. So let's go ahead and create that series. The series, well, we need the numerator, and it's going to be divided by the denominator. The numerator here is just going to be the weight in kilograms. And then the denominator is the height in meters. Okay, so height in meters. And don't forget to square the bottom, the denominator, because that's part of the formula. So I'm squaring the denominator. Okay, this expression, it looks like we're dividing two numbers, but it's not really dividing two numbers. This numerator is actually a series. So this is like a list of numbers. And we're dividing it by another list. So it's doing a lot of work here, actually. I know it looks like just two numbers, but it is not. This is a bunch of numbers. So yeah, people kind of seeing what's happening here. All right, so basically, let me pull this another cell up. So our data structure looks like this right here. Basically, we're taking this numerator and dividing it by the height, but we're doing it for every single one. There's a lot of magic happening here. So it's kind of like the beauty of Pandas. It does a lot of work in the background for you. So this is giving us not a single number. It's giving us a whole series. Just to prove it, if you were to look at the type of here, the type of this whole thing is a series, which is you can go ahead and put the series back into the data frame if you wanted. So I'm going to put it into the data frame. This is a series, so I'm going to put an equal sign here on the left, and then say store it into a column. I'll name it BMI. So this is going to take the series and put it into this column. Okay, let me go ahead and press play here. So press play. Again, there's no output. Let me put DF here at the bottom. So Jupyter Notebook will show the result here. Press play. Scroll up. Here we go. We see a brand new column. And this column is all of their BMIs. Pretty cool, right? People see what we're doing here. It's pretty powerful. Very powerful stuff. This is, in my opinion, easier than writing a bunch of loops and modifying the data structure. Okay, any questions about this so far? All we've done is pretty much talk about mapping. We're taking a current series and translating into another one and inserting it back into the data frame. That's all we're doing right now. Okay, no questions so far. All right. let's see. Let's carry on then. So our data structure now has BMI. We can do a lot of things with this. We're gonna move on to something called filtering. We'll talk about filtering, and then later on we'll talk about reduction. But basically, filtering means that we only care about certain rows or certain values, and then reduction means that we're collapsing like a sequence into a single value. This is stuff from last week. Okay. It's stuff from last week, but we're going to do it a little more automatically. All right, here, let's talk about filtering. Let's see. Our current data frame looks like this right here. It's got 1,033 rows. Sometimes it's necessary to filter data because maybe you only care about certain things. Like, let's say we only cared about people in the San Francisco team. The San Francisco team is somewhere in the middle. If we wanted to filter them, we would have to create a kind of like a Boolean expression that represents the filter. So if we would look at all the teams right here. So I'm going to put the team in here. It's going to give us a series. The head and tail. The head, first 5 people are in the BAL. And then the last 5 people are in the STL. I don't know what these stand for. It's like some sort of team. Here, let me look it up. BAL MLB. What does BAL stand for? Baltimore's. And then STL. What does STL stand for? St. Louis Cardinals. Yeah, so that's just their team. If we only cared about the San Francisco Giant, we would create like a kind of like a Boolean series that represents where it's equal to SF. So here I'm creating an expression. It's kind of like a Boolean expression that returns true or false. But in this case, it's going to give us a bunch of trues and a bunch of falses. So if I press play here, it gives us a series. This expression, it does look like it's supposed to give us a single thing, but no, it doesn't. The reason why is because this left side is a series, and we're pretty much comparing all of the elements in the series to this right side. So this series is giving us a bunch of false, and this makes sense. It's saying that the first 5 people are not SF, and the last 5 people are not SF as well. But there are some trues in the middle. If you were to kind of look at the middle, there's gonna be some trues. Here, I'll take a look at it actually. I'm gonna spam my terminal here. So yeah, once again, Jupyter Notebook here, it's kind of inhibited. It's only showing us the representation. So if I were to print it, it's actually gonna print everything. So I'm gonna go ahead and print out the whole series. It didn't print out the whole series. Huh. Okay, interesting. Press play again. I'm trying to get it to show the middle. Okay, well this isn't working. So you know what? I'm gonna do a classic for loop to iterate through this series. Just so I can print everything. You don't have to do this, but I just want to prove that there are some trues in the middle. So let me convert this into a for loop. I'm going to say for something in this series. That once again, this is a series. It's a sequence. So this something represents every element here. I don't know a good name for it yet. I'll think about it in a bit. Let's see. So yeah, I guess a good name for it is for Boolean. For let's see, what's a good name for I'll just keep it general. I'll just say Boolean. So for each Boolean in this series, I'll go ahead and print it. And yeah, there's some trues down here. It's kind of far. I have 1,000 lines right here, so I got to scroll through a bunch. Scrolling. Here it is. There's some trues over here. So yeah, there's trues in the middle. Okay, let me scroll back up. Okay. So yeah, this series has some true in the middle. You can imagine this as a filter. This is a series of Booleans. We can use this as a filter. This is the part where it's going to look a little tricky. Basically, Pandas has some kind of like proprietary syntax, meaning that they made some decisions with how they treat their square brackets and their equal signs and all that. So it's gonna look like weird syntax, but it's just whoever invented Pandas made it like this. So this is a filter. Let me comment this out here. This is a filter. If we were to insert this as an index to the data frame, so here's a data frame, and inside of these what's it called? These square braces. If I were to put the filter in here, this will evaluate to a data frame where the rows are true. You know what I mean? So it's going to give us a smaller data frame. I'll press play here. So let me press play. Okay. So I just pressed play. Jupyter Notebook is showing us the representation of this data frame. This is actually like a sub data frame. It's a filtered data frame. Basically, it's a subset, and it only shows the rows where the team is SF. And it looks like it's good. See all these SFs over here. Yeah, it looks like we're good. Okay, people cool with this so far? It's a little tricky. I think the tricky part here is the syntax, where this part that I'm highlighting. In classic Python, this isn't really like it doesn't make too much sense, but the inventors of Pandas kind of made it like this. So yeah, any questions about this? The filtering? Okay, this is useful stuff because sometimes you want to narrow down the data set. Like if we wanted to look at all the tall people, let me do this again. Let me look at all the tall people. So our current data frame, once again, is untouched. Just to make sure, right, here's our whole data frame. It's untouched. We still have 1,000 rows in here. If we were to, for some reason, filter out the tall people, like if we only cared about people above 80 inches, then we would first create a filter. So it's like a Boolean filter. I know this looks like it gives you one value, but it doesn't. It gives us a bunch of values. It gives us values where it's false and true. There are some trues in the middle. But basically, it's pretty rare for someone to be over 80 inches. So if we were to use this as a filter, once again, this is a filter, or more specifically, it's a Boolean series. It's a Boolean series, and we're going to use it as a filter. We'll use it as a filter. Okay, so let me comment this out over here. So in order to use it as a filter, we basically grab the data frame and then inside of this index, basically put in the filter. So this is saying, hey, data frame, but only give us the rows where this is true. So let me press play here. Let's play, and there we go. We have a very small data set now, or we have a filtered data set. And yeah, this is looking good. It looks like the tallest, the height here is all above 80. Okay. Cool. Let me, I'm just curious. What about the equals equals? Let's see if there are any people that are some specific height. Let's see, what's my height in inches? I'm just curious if there's anyone that's my height. Let's see, I'm like 5'5", so what's that, 65 inches? 65? Yeah, I think I'm 65 inches tall. I'm not sure. So if I were to create a filter that says, hey, give me people who are 65 inches. Let's see. I'll press play. Oh, damn. Okay, it looks like... Wait, really? There's nobody? There's nobody that has 65 inches as height. Wait, did I get my... Huh. Okay, I'm kind of just sanity checking this. That's interesting. Very interesting. I guess I'm too short for a Major League Baseball player. Or, you know, maybe I got unlucky and there's someone that's 64 inches and there's another person that's 66. So let me generalize this a bit. Let me say, give me all the people who are less than 65 inches, which is 5'5". So let's see. Press play. Okay, it looks like nobody's under 6 feet inches, 6 feet or 5'5". Interesting. Here, let me just increase this number a bit. 69. Okay, it looks like there are a bunch of people under 69 inches. And it looks like the shortest person here is 67. So that's like 5'7". Okay, cool. I just learned something today. So I pretty much learned that this data set back in the data set is pretty old, and it looks like there were no people that were my height. 65. Interesting. What about people of my weight? Let's see. I'm just curious, right? It's always good to explore data and kind of sanity check things. So let me see. Let me look at the weight. Let me look for people who are maybe less than 100 and something. How much do I weigh? Let's see. I forgot how much I weighed. I think it was like 135 or something. 135 pounds. So let's look for the people who weigh less than this. Let's see. Nobody. What? That's crazy. I guess I'm too small to be in the Major League Baseball players. Let's go 140. 140. Okay. Looks like there's no one under 140. Let's go 150. Okay, nobody under 150. Interesting. Okay, but there's a lot of people under 160. Okay. Cool, cool. Good to know. Good to know. All right. People kind of getting a sense on what we're doing, though. We're pretty much just talking about filtering. So, any questions about this so far? Let me change this back to the height. Yeah, this is some cool stuff in my opinion. Back in my grad school days, I did a lot of machine learning. Machine learning is you're creating algorithms to learn from data. So I find it interesting I find it very interesting to go through large data and kind of analyze what's happening. Okay, let's move on. So this is useful stuff because in the future programming assignment, you'll be able to filter the data set based off your team. Okay, let's move on. Okay, finally, there's something called reduction. This is a way of taking a sequence of things and generating a single value from it. For example, maybe you want to do some statistics. Like we wanted to maybe find the average of a column. Maybe you want to find the smallest number or maybe the biggest number. Just some stats. So those all involve reduction algorithms. And you know what? Pandas comes with many. There's these statistics function here, which pretty much will allow you to do that. Like if I wanted to look at the tallest person, we would look at the height. So here, let's build up to it. So the data frame height right here. Once again, this gives us a series. And this series has some class functions that we can use. Oh, I didn't even talk about classes yet. Okay, we'll talk about classes in like 2 weeks. But basically, it's got some dot functions, meaning that I could do something like a dot average, or what is it, dot mean? Yeah, I could do like a dot mean here. It's gonna take the whole series and then kind of iterate through it for us and calculate the average. So it's the average here is about 74. Once again, don't worry about this mp.float. This is just it's like a fancy decimal. So if I were to print it, it's gonna give us 73. Pretty cool, right? People kind of seeing what's happening here. There's a lot of magic that's happening. But basically, when we do the dot mean function, the magic in the background is it's iterating. There's like a hidden for loop that goes through all of the numbers, sums them up, and then divides it by how many people there are. So this is the average. This is the average height of every single Major League Baseball player at that time. All right, here, let me back up a bit. We should probably filter the data set, maybe because we only care about certain statistics. Like let's say we only cared about people in the San Francisco team. Well, currently this mean includes everyone. So we would have to calculate the mean on a filtered data frame. So let me scroll up a bit to look for the filtered data frame. We did one earlier that filters based off of team above here. So scroll up a bit. You remember this line of code? This evaluates to a smaller data frame. So let me use this. Let me use this over here. Scroll down and paste over here. So I just pasted it. Once again, this is an expression. It's not really gonna do anything. If I press play, right, you see this first line doesn't really do anything. It's kind of like a floating value. It's kind of like putting like a 1, 4, 8 here, right? It's pretty much analogous to what we're doing. These aren't really doing anything. This is actually doing something though. So anyways, this first line of code is evaluating to a smaller data frame. If you wanted to, you could store this into another one. I'm going to set equal to, meaning the left side will represent a variable, and the variable will kind of point to this filter. So I'm going to call this like SFDF, which stands for San Francisco Data Frame. You can call it whatever you want. So San Francisco Data Frame. Let's make sure we let's sanity check it actually. So I'm going to sanity check it by looking at the length of it. So the length of the DF, this is going to give us how many rows there are. And let me print it. So this is going to give us, let me put this in an F string. I'll put this in an F string. I'm going to say SF has has this many players. Okay, let me press play here. Press boom. Okay, SF has 34 players. Cool. So we sanity checked that the data frame is, yeah, it's filtered. If you want to do another sanity check, you could put SFDF here as the last line in the cell, and then Jupyter Notebook will show us. Yeah, cool. It looks good. It looks like our San Francisco DF data frame is correctly represented. So if we wanted to perform some math on it, like calculate the mean, well, we would just have to reference this San Francisco data frame instead, because this is now the smaller filtered one. So here I could go SFDF and then look at the average height of the San Francisco players. In this case, the average height of the San Francisco players is hold up, it's spinning right now. I don't know why it's taking so long. Oh, okay, it crashed. It crashed. Let me refresh this. Unfortunately, I didn't save my changes, so I think I might lose some data. Let me restart this. Okay, restart. Did I lose my data? Let me see. Well, this is a frozen notebook. So let me refresh this. Okay, I already did that. Damn, I think I lost data. Let me refresh this again. Okay, it looks like the server is glitching out. So a good habit is to save frequently. If you want to get in a habit of pressing the save button over here, you should be good. Okay, let me rerun everything from the top. And you know, I'm gonna clear the kernel just to be safe. Sometimes you might mess up your data frame, and it might be necessary to restart the kernel, which pretty much cleans all of your variables so you can rerun things. All right, let me clean it up. So I'm just gonna restart. Okay. Okay, there it is. Now everything's all blank. I mean, not blank, but I cleared the kernel. So let me just run everything again. Run. Okay, and then adding new columns. Okay, let me add another column. Add this BMI column. And okay, did I add the BMI column yet? There it is. And then hold on, let me refresh my notebook. It's glitching again. I think this server is glitching right now. Okay, let's see. Kind of lost track of what I was doing. So here, let me just load these back up again. Press play. Play here. Play here. What were we doing? Oh yeah, so we were talking about calculating the mean of a filtered data frame. And currently we filtered it, and we have a data frame called SFDF. So if we were to look at the average, we would just put SFDF right here and then press play. And yeah, it looks like SF has 34 players and their average height is 73 point something. Okay, so yeah, this is an example of a reduction algorithm. Basically, a reduction algorithm, you can take a series. In this case, we're taking a column and kind of just collapsing it to a single value. All right, so yeah, there's a few functions. Let's see. Let's say we only cared about the tallest person, like the max. Basically, I'm saying there is a reduction function called max, and it will give us the biggest number in that series. So let's do that real quick. Let me look at it. So I'm gonna look at the smaller data frame, the SFDF. So here's the. If we only cared about the tallest person, well, we would look at the height. So here's the height in inches. This gives us a series of numbers. If we were to do like a dot minimum here, then it's going to collapse this whole series into a single height. In this case, it's going to collapse it down to the number 68. The number 68 represents the what's it called? The shortest height on San Francisco. So if you wanted to store this in a variable to make things a little easier to read, you could say something like shortest height is equal to this, and then go ahead and print the shortest height. Let me do this in an F string. There we go. So yeah, the shortest height on SF is 68 inches. All right, people cool with this so far? Okay, cool. You know, sometimes it's necessary to find out who is associated with this number. You know, like maybe we wanted to maybe we wanted to get the name of whoever is 68 inches. So, you know, in this case, it might be necessary to use this number as a filter. So here's what I mean. Basically, the shortest height is a number. We could create a filter off of it, where we could say something like SFDF, and then look at the height. We could say, hey, give me a series where the height is equal to the shortest height. The reason why we might want a series is because multiple people might have this same exact height. So there could be ties. So this is, once again, this is a filter. It's a Boolean series. Here, let me press play. So I'll press play here. And yeah, so this is a Boolean series, and it's evaluating to a bunch of falses, a true here. So it looks like there's one person that's 68 inches. And yeah, it looks like that's about it. So we could treat this as a filter, meaning that if we put it in the quotes, I mean, not the quotes, this index. If we were to index into the data frame with this filter, so I'm pretty much gonna cut this filter and paste it into these here. So I'll cut this filter, paste it here, and then this is going to give us a much smaller data frame. The data frame is going to represent where this filter is true. So let me press play. And okay, cool. Yeah, it looks like Ray Durham is the person that has the 68 inches. If you wanted to print out the name, well, it's gonna look a little weird here. You know, this is technically a data frame that we're looking at. It does look like a singular row, but there could possibly be ties. So in this case, there's only one person on SF that has 68 inches, but it's possible for there to be more. So yeah, basically I'm saying that this is a data frame. If we were to look at the type, just to prove it, this is a data frame, meaning that if we wanted to access a single row here, one way we could access that row is by indexing. It's called the index location idlock, and if we set idlock 0 here, it's gonna give us this very first row. So let me press play here. There it is. It gave us the very first row, which is Ray Durham, and then here's all of his other features. So this is actually no longer a data frame. This is like it's like a series. If you take a look at the type of it, it's like a series. A series is like a fancy dictionary where the keys are here, name, team, and then the values are here. So this is gonna look weird, but this whole thing I highlighted is like a dictionary. So we could access things with another. We could access values with this square brackets. The square brackets here, if I put name, this is saying, hey, grab the dictionary, but give us the name associated with it. So it's gonna return Ray Durham right here. So Ray Durham. And if you wanted to, this is the shortest person. Shortest person is equal to this, and if you wanted to print it, you could print it. So you could say that person is shortest person right here. People see what we're doing here. Pretty cool stuff, right? Okay. Let me think real quick. Okay, I hope people are cool with this. Here, let me take this a step further. I'm curious how many people are 68 inches tall. Not just on the SF team. So let me change these variable names. Shortest height, this is technically the shortest height in SF. And then technically this is the shortest person in SF. So let me just make sure it runs. Okay, I'm curious. Out of every Major League Baseball player, I'm curious how many people are 68 inches. So let me do the same thing. Basically, I'm going to create a filter, but the filter is going to look at the whole data frame instead. The whole data frame is once again DF. This remained untouched. So if I look at DF, this is the 1,000 rows here. I'm curious, so let me create a filter where we're looking to see where the height is equal to the shortest person in SF. Shortest height, I mean. So this is a series. It's a series of booleans. And if we treat this series as a filter, so I'm going to treat it like a filter, but basically I'm going to use that. I'm going to pretty much cut this into this square braces. If we put the filter down here, this is going to give us a smaller data frame where the filter was true. So let me press play here. Press play. Okay, yeah, it looks like there's a bunch of people that has the same height as the shortest person in SF. Just to sanity check it, we have this person, got this person over here. Yeah, we got more people. So yeah, this is like another filtered data frame. Okay, pretty cool stuff, right? Any questions about this so far? Yeah, this is some pretty cool stuff. Yeah. So just to summarize what we did so far, we're talking about pandas, short for panel data, and we're pretty much scraping the surface. There's so many things that we could talk about. I've taken like I think 3 different machine learning classes, and a lot of those machine learning classes would use pandas as like a learning tool, pretty much to study data. And yeah, it's pretty cool stuff. Basically, if you study data, you can make predictions off of it. In machine learning, these columns are known as features, and you can predict other features based off of these features here. Let's see. It's kind of like you can think of social media recommendations. If you have like a Instagram account or a TikTok account, whatever, basically there is some data in the background. The company is storing you in a database. That database stores your features. It even stores your history. So you can imagine that there's kind of like a column that represents your history. And based off of those features, the company can write algorithms, go through your features, and recommend you things. Like they could look at your features and be like, oh, this person is interested in something, and that something, it relies on their other features. So yeah, this is pretty cool stuff. Data science is the backbone of machine learning and AI stuff. A lot of people refer to AI nowadays as like large language models, like, ChatGPT and all of that. But those are like machine learning models that learn from big data. So yeah, pretty cool stuff. We're only scraping the surface. There's literal courses dedicated to pandas. Let's see. Okay, finally, there's some plotting here. Sometimes it's necessary to communicate ideas to other people. As a computer scientist or a programmer, you might want to make things look easier to read for other people. Like, let's say you wanted to generate some statistics and you wanted the general audience to kind of understand it. Well, the general audience wouldn't really understand, these codes here, but they might understand pictures. So if you wanted to generate some diagrams, you could do that. For example, we could look at the histogram. A histogram is kind of like it's kind of like a frequency counter. It pretty much counts how many people has a certain BMI. Here, let me play this. Oh, I need to create a new cell for this. So create a new cell down here. Okay, so let me look at this. Basically, this is a histogram. The histogram is like a frequency counter, and it tells us how many people have a certain BMI. It looks like most people have a BMI of like 26 right here, or a 25, whatever. And then there's some outliers on the side. Like over here on the left, this is a low BMI. Not a lot of people have low BMIs. And then the high BMI here, it's some outliers. or no, no, not really outliers. They're just far away from the mean. Okay, so yeah, this is a histogram. You can generate more things if you wanted to. If you're curious, you could look at the API reference for pandas. So you could look at it, and let me look at the left to see where the plots are. Plotting Andrew's curves. Interesting. I didn't even know that this was a thing. Andrew's curves. What the hell is this? Let me see this. Generates. Okay, some math stuff I don't understand. Let me back out of this. Oh, this is for visualizing clusters of multivariate data. Oh, okay. This is actually pretty cool stuff. So multivariate data, this is outside of the scope of this class, but basically data can be multidimensional. Currently we're working with two-dimensional data, but as data gets more complicated, there's more dimensions. So yeah, it looks like this is pretty cool. I see what it's doing. It's pretty much going through all of the features and calculating some sort of metric for all of those features. X1 here, this represents like the first column. X2 represents like the second column. Okay, anyways, this is outside of the scope of the class, but it's some pretty useful stuff if you're like studying patterns in data and stuff. Anyways, here, let me look at more plots. So going down here, let's see. I'm in the wrong place. Let me look at the data frame. So the reason why I should probably look at the data frame, or series actually, is because this is a series, the part that I'm highlighting, and it looks like this series has like a dot plot, and this dot plot has a histogram. So let me narrow it down a little better. Let me look at the series first. So series. Okay, series. What about dot plot? Is there a dot plot here? Dang, that's a lot. Let me control F this. Control F. Okay, there it is. So there's a series.plot. And then this series.plot, let me scroll down a bit. Yeah, it looks like with the series, we can have multiple types. In this case, we use a histogram. But you could do bar diagrams, you could do lines, and a bunch of other different ones. You could do a pie plot too. A pie plot gives us, it's pretty much like frequency again. Yeah, a lot of cool stuff. Oh, it looks like they have some examples here too. Nice, nice. Data frame plot. Yeah, cool stuff. Okay. So yeah, here's our histogram. I want to skip over this bottom of the notebook, this complex filters. Pretty much if you're planning on being a data scientist, you might want to take a look at this section. Basically, it's doing some fancier things with filtering. You don't have to know too much about this, but yeah, it's only, I think you should take a look at it if you're a future data scientist. So I'm going to collapse this over here. Okay, cool, we collapsed it. Yeah, we're pretty much done with the notebook. The biggest takeaways from here are pretty much just using the Pandas library to automate things. You see how things are so much cleaner? they're so clean. Like we didn't have to do any for loops to iterate. We didn't have to do any if statements. It's pretty cool stuff. So with this in mind, you should be able to do this next programming project. The next programming project is right over here, lesson L18. Let's see. I'll let folks look at it later. Yeah, you should be able to do it now. Okay, so yeah, that's it for today. Once again, we're ending like 45 minutes early today. The reason why is just so we don't get too overwhelmed. there is a lab associated with this, number 18. I would probably suggest doing the project before the lab. It's probably going to flow a little better. The reason why is because the lesson that we just covered transitions very well to the homework. And then after you finish this Major League Baseball player's homework in Pandas, you could probably work on the lab. The lab 18 over here. Let me pull it up. Lab 18 over here is dealing with a different data set. So I would probably do this lab after the Major League Baseball players. Not this one. This is the old one. But I'm talking about the new one. And then on Thursday, in 2 more days, I'll probably go over this new data set. It's pretty much all of the airports in the world, and we're gonna analyze all of the airports in the world. So yeah, that's pretty much it. Okay, here, let me look at the future of the class real quick, and then we'll end it. Okay, let's see. So we covered lesson 18. You have enough to do the project. Let's see, the lab, probably save this for later, probably like 2 days from now. Thursday, let's see. You know what, Thursday, I think we might have time for data structures. Yeah. In the beginning of class, I said that we might have to shift this to next week. I take that back. We have enough time to get data structures done on 19. Okay, and let's see. Next week, we'll be covering our last topic, classes and objects. So this is called object-oriented programming. This is a kind of a different style of programming. And then the second to last week looks like we have a catch-up week. We'll deliver a practice final, and then the final exam is on the last week. So just a heads up, our final exam is a different schedule, by the way. Every class has a different schedule for final exam. It's just how the Cabrillo works for the 16th week. So if you're taking any other classes, you might want to check in with your professors to see when their exam is scheduled. Our exam is scheduled at some time. Let me look it up. So you can Google up Cabrillo final exam schedule, and it should show up. So I'm Googling up Cabrillo. Okay, it didn't even show up. Is it over here? Class schedule? Class schedules. Oh, here it is. Here it is. So final exam schedule. So let's see. So our exam, let's see. Let me see when it is. So our class is Tuesday, Thursday, and it starts at 6:30 p.m. Tuesday, Thursday, 6:30 p.m. Wait, hold up. We're not even in this. Okay, hold up. Give me like a minute. Where's the 6:30 p.m.? I'm basically looking at this left column and looking for where Tuesday, Thursday, 6 p.m. is. It's not even showing up. For the final exam schedule, evening classes are those that begin.
It was back up there. It was with 3 something and 6:30.
Oh, okay. It was back up here. 3:30 and 6:30. Somewhere up here. Hold up, Jim. I couldn't see what you're looking at.
I think I saw it.
Okay.
I saw like a 3:40. No, maybe it was a 5:30.
Oh.
Sorry.
It's all good. It's all good. Here, let me keep looking. Tuesday. Man, this is hard to read. They could have made this easier. Oh, let's see. Tuesday only. Or Tuesday and Thursday. 6. Okay. I think our exam is on Tuesday, December 9th. And we'll have 3 hours to do it. Typically, our class lasts for 2 hours. But on the final meeting, it's going to be 3 hours. Starting at 6 o'clock instead of 6:30. I'll make an announcement later, so you don't have to skim through all of these. I'll make an announcement like next week or something. Okay, so yeah, that's just looking ahead in the future. Make sure you check in with your professors. If you can't check in with the professors, you could read through this Cabrillo final exam schedule. Okay, yeah, that's some good stuff, folks. So, I really wish we could talk more on pandas. I tried my hardest not to do too much and kind of just scrape the surface instead. This is some really, really great stuff. A lot of my research in grad school used pandas to kind of do research. if you're curious, I could pull up some of my research right now. I did some research. Let's see. So projects. One of my research here was called collective graph identification, which means to look at a social network and predict what people might do. Not what they might do, but kind of predict relationships, and maybe predict what people do for a living, and other features. So pretty much, you can imagine like a data set of emails, and you can go through that data set of emails and pretty much predict what people do. You can predict their relationships. You could predict their maybe job position, and you can also predict people with the same entities. Like some people might have the same emails, so you can kind of predict who has that same email. And this collective graph identification used pandas. So here, I just clicked into it. I have some scratch pads here, but this is pretty much me using pandas to go through a large data set. In this case, this is actually the Enron data set. If people heard of Enron before, Enron it was a company. It was an American energy company. And something. Say that again, Jim.
The crooked E.
The crooked E. Yeah, the crooked E right over here. And I think at some point, all of their emails were released to the public. Let me look through it. I don't know too much about the history here. Pretty much my job was to go through some data and do something with it. I wasn't really aware of how that data was obtained. But let me see. There was... Let me look at the emails. Oh, here it is. So back in sometime, all of the company's email got archived. And you could look at it. You could look at it over here. So this data set contains 250,000 emails. It contains a bunch of contacts, different companies, and even phone calls. So you can imagine that all of this data is stored in some sort of data set. Let me look it up. I'm gonna Google it. Enron data set. So Enron email, here it is. So it contains a lot of messages. Let me see. Where's the download button? let me Control F this and look for the download. Okay, I can't. Oh, here it is. Here's a download button. I'm not about to download it. It's a pretty big data set. Oh, it's actually not that big. It's like 2 gigabytes. But yeah, you could download 2 gigabytes worth of text, and that text will pretty much look like it could look like well, actually, it's gonna be dirty data. You're gonna have to clean up the data a bit. But if you do clean up the data, you can end up with a comma separated values, which is the CSV file. And then you can take that CSV file and then go through it. So once again, here's kind of like a scratch pad. I'm importing pandas, and then using pandas to go through all of those emails. And I'm pretty much going through this person's email. This person sent 128 emails. That person also received 606. And then there's like a bunch of other features here. These other columns represent their language. So each person has like a different language. Not different language. I'm talking about like the way they speak or the way they write. So there's a lot of columns here. There's actually like 5,000 features. There's like 5,000 features, and you can write algorithms that go through each profile and kind of just you can predict things. It's some pretty cool stuff. I spent a solid 1 year on this project. And then in the end, I had to write a paper on it, get it published, and help me graduate from grad school. Actually, I think it took me like 2 years to do this. Yeah, it took me like 2 years. But basically, it took me 1 year to learn how to use this software called PSL, and then it took me another year to actually go through the data, and then it took me a bit of time to write some papers. But anyways. Yeah. I just want to say, Pandas is really great stuff. It's really great. For this
After
class.
all that,
Yeah. Go ahead, Jim. Sorry.
After all that, did you have a decision on what the culture of Enron was?
Good question. No, I didn't. We didn't. We should have though. Are you aware of any cultural things that they have?
Enron screwed over California energy-wise, and they're probably the reason why we have some of the highest energy costs of any state in the union, was because what Enron did to us during the Gray Davis administration, where they actually switched off power plants on days of high power demands. And they were extremely nefarious.
I see. And they had some scandals, some insider trading, maybe.
Yes, they were jobbing the energy market, and they were artificially inflating the spot prices on electric prices, and yeah, they ran us through a lot of grayouts and blackouts.
Dang.
When was that? 2004 maybe. Yeah, it was a very tough time.
Interesting. Yeah, I should have. During this project, I was really just focused on the technical side, the technical side of going through data and predicting things. I actually didn't really question the history of the data, but I should have. I should have.
I think Enron is an example of a very, very evil corporation.
I see. No wonder why their data set was published. All their emails and communication.
We don't want to see another crooked E.
Yeah. 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 Good stuff.
I think
And
this Panda is an incredible tool. It's just amazing, and thank you so much for sharing that. I'm really looking forward to delving deeper into it.
mhm. Yeah, it's some good stuff. I do recommend that the data should be clean beforehand. I don't recommend loading in dirty data. Um, by dirty data, I mean like there's blanks. If you have like blanks in the data, then it could mess up your results, and
Mm.
it could skew your results. But yeah, if the data could be as clean as possible, then yeah, pandas will have an easier time. Yeah, good stuff. Good stuff. Feel free to let me know. This is actually I used to teach machine learning at UCSC. This is one of my favorite topics, just data science, and building AI algorithms and all of that. Yeah, feel free if you want to talk to me a little more about it. Okay, but yeah, let's stop here. Next week, 2 more days, we'll talk about data structures, and then finish up the class next week. Thank you, Jim, for the feed for the for the info. That's some good stuff. All right, everybody have a great day.
Good night.
Stop. Yep. Good night.